Welcome back, you guys. Let's get going on example 11. So on the next 6 examples, it says all triangles are similar by blank. So after we do the first problem, it's probably going to give it away because all the triangles in the next 6 examples are similar in the same exact ways. And then after we show how the triangles are similar, we will use that information to help us find the value of x and the value of y. So there'll either be some sides or some angles that we don't know that we'll need to solve for using our similar triangles. So let's see what happens. Okay, so the first step is I need to know how these two triangles are similar, which in our picture, we have this top triangle right here. Okay, I'm going to shade in yellow. Okay, so we have the top triangle, which if you guys see here, I've drawn it over here because we have some overlapping triangles going on. And I also have this bigger triangle. So we have triangle OEW, and then we have triangle OMS. So we have this big triangle right here, which is down here. Okay, so I've separated the triangle so you guys can see it a little bit better. All right, now currently if we look at our triangles, which I'm going to transfer our sides onto this triangle. So my little triangle, we have 4, x, and y. So we have a 4, an x, and a y. Okay, on the bigger triangle, now remember, to find side OM, I need to know the entire side length. Okay, which OE is 4 and EM is 2. So how do I find OM? You guys are so smart. You would have to add these two together. So I need to add this piece and this piece together to get OM. So 4 plus 2 will give me a 6. So this side is actually 6. The bottom, MS, is 6 as well. Okay? And then I'm trying to find side OS as well. So OS, again, OW is Y, and WS is 3. So to get OS, I need to add these two together, which Y and 3 you can't add together. So I'm just going to write this as Y plus 3. Okay, that's how, I know it looks a little weird, but I don't know the value of y yet, so I'm just going to leave it. When I know y, the way that we're going to find OS is by adding these two together. Okay, so if you guys see here, in my first triangle, I only have one side, and in my second triangle, I have 2 of the sides. Okay, so the sides, I don't know. I don't know if they're going to be helpful for helping me to find anything because the only similarity postulates that have sides are side angle sides, so you need 2 sides, or side similarity, which needs 3 sides. Currently, my smaller triangle, I only know one of the sides. So I don't know. I don't think SSS and SAS is going to work in this one, unfortunately, which means probably my only other option is AA. But you're probably like, Miss Long, nothing's marked in your picture as congruent, which is a problem. Well, it is a problem, but there are some nifty tricks up my sleeve that I can use to find some additional congruent angles. One of which we solved in example 10. So if you think back to example 10, do you guys see any angles that are the same in triangle OEW and triangle OMS? If you guys see here, they both are sharing angle O. Okay, if you guys see the little triangle and the big triangle both share angle O. So first of all, I can say that angle O is congruent to angle O by, what is it called when we have a shared angle or side? Heavenly hamburger, you guys. It is the reflexive property. So I have one angle shown to be congruent. If I want to use angle though, I need to show that 2 angles are congruent. Now, you probably have noticed some additional markings in my picture. Do you guys spot these sneaky little arrows in my picture? Do you guys see them? What does the arrow mean? When we write arrows on our picture, what does that mean? It does mean that those two are parallel. Okay, so if you ever spot any of those parallel lines, guess what? That means any of those angle pair properties when we have parallel lines could pop up. So you might see things like alternate interior angles. You might see things like corresponding angles or alternate exterior angles or same side interior angles. So we're kind of looking for one of those letter shapes to appear in my picture. So I'm going to mark it on my original picture so you guys can see it a little bit better. Okay, so do you guys see like a F or a Z or a C? Do you guys see any of those things appearing? I see it too, you guys. Do you kind of see the F? Whoa, do you guys see the F? See, there's kind of an F right here. Do you guys see that? Which there's actually two Fs. There's one going this way, and there's also one going this way. So there's an F here and an F here. Okay, so technically I can say that angle M is congruent to angle WEO, or I could also say angle S is congruent to angle WEO, and then EWO. And both of those are congruent because which angles form the F? Do you guys remember? Of course you remember. It is corresponding angles. So I could use either these two or these two to prove that these two triangles are similar by angle because you only need two angles. So I can either pick one or the other in addition to my reflexive angle. So you have lots of options on this one. So I can also say that angle, you have two options. I'll write in both, but you don't have to. Okay, I'm going to say angle OEW is congruent to angle M. Okay, or you could say angle OWE is congruent to angle S, and both of these are for the same reason because they're corresponding angles, and corresponding angles are congruent by the corresponding angle postulate. So this would be because the corresponding angle postulate. So guess what, you guys? My two triangles are similar by angle similarity. Nice. So probably all of my examples are going to be similar by angle because it says all triangles are similar by the same thing. So we already know that the answer is angle. So in the next 5 examples that you do, we're going to be looking for angle. So just keep that in mind. Okay, now usually we would be done after that. But on these problems, we have some extra steps. In addition to finding out how they're similar, we're also going to find X and Y. Okay, so now that we know our triangles are similar, guess what? That means all sides are proportionate. So we can set up proportions to solve for any missing sides that we have. Okay, so first we're going to tackle X right here. So if you guys see here, X is right here. Now, remember, when we set up a proportion, we want to make sure we write the corresponding sides together. Guys, now, if you see here, like if I look at these two triangles, 4 and 6 correspond, X and 6 correspond, and Y plus 3 correspond. And how I know that? Technically, they're not drawn to scale, but you can kind of look at your congruent markings as well. So, let's see here. I know that like these two are congruent and these two are congruent. Okay, so 4 and 6 are both in between like the 1 and 2 arcs. Okay, 6 and 6 right here are both in between the 2 and the 3 arcs. I'm sorry, 6 and X are both in between the 2 and the 3 arcs. And Y plus 3 are both in between the 1 and the 3 arcs. So that kind of tells you which sides correspond. Now, in order to set up a proportion, I have to have one fraction that I know all the values for, or otherwise I can't solve it. So the only sides that contain values for both triangles are sides OE and OM. Okay, so I'm going to use the 4/6 scale factor in both of these. Okay, so 4/6 is going to help me to find my missing sides. And since those are the only two sides that I have the values for in both of my triangles that correspond, okay, I'm going to use it to help me find X as well as Y. Now, before I get going, it's always helpful to try to reduce down your fractions because the smaller the numbers, the easier it'll be to solve. So I'm going to reduce down 4 over 6 real quickly before I get started. Okay, what is a number that will divide into 4 and 6? Correct, you guys, correct. It'd be 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. Okay, so I'm going to be using the scale factor 2/3 both times when I'm trying to find x and y. So since that will reduce down to 2/3, I'm going to use that bad boy twice. Okay, and now I'm going to set up my proportion using x. So x is currently on the bottom of my triangle, and it's in between the 2 arc and the 3 arcs. Okay, so since the 4, which now reduced down to 2, originally came from my smaller triangle, I need to start with the value that comes from my smaller triangle, which is the x. So I'm going to put x up here over the side that corresponds to the x, which x is in between the 2 and 3 arcs. The 6 is in between the 2 and 3 arcs. So I'm going to put 6 right here. All right, and now that I have my proportion set up, how do we solve a proportion? We do cross multiply. You guys are on a roll. Let's do it. Okay, so 3 times x, I'm going to move it up here, is 3x. And that will equal, let's go the other way. 2 times 6 is 12. And all we got to do is solve for x, which these two are secretly multiplying. So the way that I move 3 to the other side is by dividing. 3 divided by 3 cancels and turns to 1, and 12 divided by 3 is 4. So I know x is 4. Nice, nice. Okay, and using my same scale factor from before, that's going to help me to solve for y. So let's get going on y. Okay, so my side, to figure out y, I need to find the sides that have the y. Okay, so this side has a y, and it's in between the 1 arc and the 3 arcs. Y plus 3 is also in between the 1 and 3 arcs. And don't forget, this 4 came from my smaller triangle, so I need to write the side in my smaller triangle first, which is the y. So this will be y over the larger triangle, which is y plus 3. And now all we gotta do is solve for proportion, which you guys are cross multiplying pros, so let's get going. Okay, so I'm gonna start going this way. 3 times y, I'm gonna go up here, is 3y, and that will equal, let's go the other way, 2 times y plus 3, which I'm going to write it as 2 times y plus 3 like this because we're multiplying 2 to the whole thing, not just the y and not just the 3. Okay, so from here, the way that you deal with the number outside of a parenthesis is by distributing that thing. So this is going to be 3y equals 2y. 2 times y is 2y, and 2 times 3 is 6. And then from here, you just solve for y. So I'm going to zoom in so you guys can see this a little better. Okay, let's do it, you guys. So first, I must join my y's together. They're currently separated and they're best friends, so they need to be joined back together. So I'm going to bring my 2y to the other side to join its friend. And I'm going to subtract it on both sides. So 2y divided by 2y will cancel and turn to 0. 3y divided by 2y is 1y or just y. So guess what, you guys? I'm now left with y equals 6. Look at that. So this side you could say is 6, and this is 6 plus 3, which is 9. All right, you guys, so not only did we find out how the two triangles are similar, we were able to use that to help us find 2 missing sides on our triangle, or 2 missing values. So that was a very helpful way to do that. So that's why similar triangles are useful, so you can find missing sides on your triangles. All right, who's ready for example 12? I am, so I know you guys are. Let's get going.